All right, so let's continue. Single replacement. This is where a metal can replace a metal or a non-metal can replace a non-metal. The two general forms are as shown below. They really don't look any different. And this is where we need to make sure we understand and can use the activity series. Here are the metal activity series, and this is the non-metals. These are our halogens. So we need to look at table J, and at this point I would highly recommend that you have table J out so you can kind of understand how we use the activity series. So for example, write the balanced chemical equation for the reaction of zinc metal with aqueous hydrochloric acid. So we have zinc metal plus HCl will produce, and we have to figure out what's going to replace what. What happens is zinc is going to replace hydrogen to create zinc chloride plus hydrogen gas. Now as written, it is not balanced. So we need to place a 2 in front of the hydrochloric acid or hydrogen chloride to balance out the hydrogens as well as the chlorine. So here we had a metal replace, not necessarily a metal, but hydrogen. Remember, hydrogen doesn't really belong anywhere. So let's try another example. Write the balanced chemical equation for the reaction of sodium chloride, solid that reacts with fluorine gas. Now here we have fluorine, which is a halogen. It will replace the other halogen. So as we go through, we will now get sodium fluoride plus chlorine gas. Now, chlorines are not balanced, neither is fluorine, so if we will need to place a 2 in front of sodium fluoride on the product side, which will then need to require a 2 on the reactant side to balance out the sodiums and the chlorines, and we will place that 2 coefficient in front of sodium chloride. We're now balanced. So, hopefully we have a better understanding of the product or predicting our products. A double replacement reaction is where you have a compound and a compound that will produce a new compound and a new compound. Now typically you can think of it as the foiling process that you've used in algebra. Typically what I like to do is just switch around the 2 positive ions and you're done. So write the balanced chemical equation for potassium sulfate and barium nitrate. Now what's going to happen is potassium is the positive ion, barium is the positive ion, and you'll notice the positive ion is written first. So potassium will replace barium, and then barium will take the place of potassium. So we should end up with the following: barium sulfate plus potassium nitrate. Now, since we have polyatomic ions, we'll want to make sure we balance those as a unit themselves and not break them apart. Now, we'll practice predicting some products and balancing the reactions below. So we have dihydrogen sulfate, also known as sulfuric acid, plus sodium hydroxide. This is a double displacement reaction. So we will have sodium replace the hydrogen, and this hydrogen will replace the sodium. Here is another double displacement reaction where potassium will replace copper and copper will replace potassium. Same thing here, iron 3 chloride plus sodium hydroxide. The iron will replace sodium, and remember the iron will maintain its positive 3 charge, and the sodium will then take place with the chlorine. So here we have potassium plus magnesium bromide. The potassium will replace the magnesium, and the magnesium will be alone. Here, what type of reaction is this? This is, since it's no positives on this side of the reaction, this will become a decomposition reaction. Therefore, keep in mind, this is the carbonate, so we will end up with lithium oxide plus CO2 gas. So let's check your understanding. This here, again, is a decomposition reaction. This is a combustion reaction. This here will be a combination and/or combustion. This is a single displacement, and this is a double displacement. Good luck.